Hello. Yeah. Good morning, everyone. We were talking about land-based classifier. Yesterday we saw the previous class. We saw one example regarding that. Yeah. Today we shall see one more example. Few more examples. How we can use land-based classifier to solve these examples. In exam, you can expect these questions. See pattern. The data will be different. You'll be asked a different question, but the solution, the approach should be same, and you can follow this approach. They will give you one table, and they may ask you. They will give you one instance, and they will ask you to classify that new example, or they may ask you to find out the probability of to which that example belongs to which class that example belongs to. Um, so you can expect one question on this topic, one problem on this topic. Okay, you can see the data here. Where this data represents a species classification based on color, leg, height, and smell. Okay, there are two types in that species, M and H. Okay, total 8 number of examples are there, and four attributes are given. Based on these four attributes, that species is either classified as M or H. So, with this given data, they have given this question. Okay, they have see this is the given data, and they have asked us to find out the probability values for the new instance. Okay, so this is a new example where color is green, two legs, height is tall, and no smell is not smelly. So if this is the given condition, what is the probability that it is either M species or H species? So for this condition, we need to find out the probability of it being M species or H species. Is it clear? So this is the given data. We have the data, and this is the new instance to which we have to find out the probability. So first thing is you have to calculate the prior probability. Probability that this species may be M or it may be H. P of M and P of H we have to calculate. So probability of M, the among 8 examples, prior probability. So it being species M is P of M is equal to 4 divided by 8 is equal to 0.5. Probability of it being H is P of H is also equal to 4 divided by 8, again 0.5. Okay, this is the prior probability. Next thing is you have to calculate the probability for each attribute value. What is the probability of it being white based on color, based on leg, based on height, based on smell? So based on these four attribute values also you need to calculate the probabilities. So first based on color. Okay. In color we have two types, white and green. Okay, white and green. You can see here four green examples are there, four white examples are there. Five white examples are there. Three green examples are there. Okay. So see, for each attribute, you put a table and write down the probability. Okay. For each attribute, it's advised to put a table so that final calculation will be very simple. So probability of color being white, if that is white color M species, what is the probability? You can see here, m examples are 4. Among them, white is 1. Okay, among white is 1 and 2. 2 divided by 4. H species probability of being white is, okay, H species being white is 3 white. H species. So 3 by 4. Okay, M species being green. Okay, 4 M species are there. That being green is 1, 1, 2, 2 by 4. H species being green is, okay, only one example. So 1 by 4. For each attribute, you put a table like this. Next attribute is leg. Okay, M species, two-legged animal. That is only one combination, 1 by 4. H species being 2 legs, 4, 4 by 4. M species being 3 legs, 3 by 4. Here, this condition is not there. This probability is not there. Next, height. M species being tall, 3 are there. Among 4, 3 by 4. H species being tall, 2 by 4. M species being short, 1 by 4. H species being short is 2 by 4. Similarly, smelly. M species, is it smelly? Yes. How many cases? 3. 3 by 4. H species, is it smelly? Yes. How many cases? 1. Okay, only 1. So 1 by 4. M species being not smelly, only one case, 1 by 4. H species not smelly, that is 3, 3 by 4. Okay, you have to put a table like this for each and every attribute. Okay, for each and every attribute, if you put the table, it will be like this. Next thing is, we have to find out the probability for the given new instance. Okay, probability for the given new instance. Where, so this is our prior probabilities. Now our new instance. Okay, that being m. Okay, this probability of it being m with this data, new data, is equal to probability of m into probability of color green given m. X is equal to 2 given m. Height is equal to tall given m for m. Smell is equal to m. So in this table, you see the values. Color is equal to green for m, 2 by 4. X is equal to 2. Probability of being m, 1 by 4. Height is equal to tall. Probability of being m, 3 by 4. Smell is equal to no. So being m, so 1 by 4. All those things from the table, you take the values and multiply. So the new instance probability of being m species for the new instance is 0.0117. Okay. Next thing is, we have to check the probability of that new instance being H species. Okay, that is probability of H into green and H, green color and H, 1 by 4. X is equal to 2, X is equal to 2 being H. Height is equal to tall being H, probability 2 by 4. Smelly no being H, 3 by 4. So that you multiply. So the probability is 0.047. So if you compare these two probability, the new instance has got highest probability of being H rather than M. Okay, new instance probability of being H is greater than probability of being M. So the new instance belongs to species H. Is it clear? We have the data. For that data, you have to calculate the probability, prior probability, and draw these tables. for all attributes, and then substitute them in the formula, and we can find out what is the probability of it being n and what is the probability of it being h. Is it clear? Let's see one more example. Okay, here's another example. This data gives the details about the car, a vehicle, based on color, type, and origin, whether it's stolen or not. What is the probability of the car being stolen based on its color, type, and origin? So this is a given example. 10 examples are there. First thing is you have to calculate the probability of yes and probability of no. Okay. And then there they have given one more new instance. So you have to calculate the probability of this new instance. Color being red, type being SUV, and it's domestic. So this new instance is not there in the given example. You have to classify this new example. What is the probability that this new combination being yes or no? We need to classify this new instance. What is the probability of it being stolen? Is it yes or no? Yeah, just like the previous example. Here also you need to calculate the prior probabilities. 10 examples are there. Probability of being stolen, yes, 5 by 10. 5 yes are there. So 5 by 10. Probability of being no, again 5 by 10. So 0.5, 0.5. Okay. Then 3 color attributes are there. Color, type, and origin. So for these 3 types, you need to you just draw the table. Okay. For color being red, yellow, 2 values are there. Color. So red car stolen, 3 out of 5. Red car not stolen, 2 out of 5. Yeah. Probability of yellow car being stolen, 2 by 5. Probability of yellow car not being stolen, 3 by 5. Sports vehicle, 4 by 5. Stolen, no, 2 by 5. SUV, 1 by 5. See, you have to see the table, and then you have to see this data and fill this table. Okay, for these 3 attributes, respectively, you will just fill the values. And then final thing is we have to find out probability of yes, this new instance. Probability of this new instance being stolen, which is equal to probability of yes and probability of red color being yes, SUV being yes, domestic being yes. Okay, red yes 3 by 5, SUV yes 1 by 5, origin domestic yes 2 by 5. Okay, so if you multiply these values, you will get the probability of being stolen is 0.024. Okay, 0.024. Next, probability of no. Okay, what is the probability that this new instance is not stolen? Okay, probability of no into red no 2 by 5, SUV no 3 by 5, domestic no 3 by 5. So if you multiply them, you get 0.072. So probability of not being stolen is 0.072. Probability of being stolen is 0.024. So when you see the probability, it clearly says that this vehicle, probability of this vehicle not being stolen is higher. So this new instance, you can classify it as not stolen. Okay, if the car is red SUV, domestic vehicle, probability of it being stolen is less. Okay, is it clear? See, any problem given in this topic, what you have to do is first, for each and every attribute, you just draw the table, and for each values, write down the probability. Okay, if the color is red, yes or no, how many times yes is there, how many times no is there. Okay, if you write it down like this, it will be very simple, very easy to find out the final probabilities. And one more example. So, see this previous example. This was asked once in previous exam in question paper. Previous year question papers you can observe. This is being asked already. Right. So yeah, they may give new paper or old one itself. Problems might be changed. So you may expect a problem on this. And one more final example. Okay, consider a football game between team A and team B. Suppose team A wins 65% of the time and the remaining matches is won by team B. Among the games won by team A, only 35% of the comes from playing at team B's football field. Okay. See, overall, A has won 65% of time. But among them, 35% of time they have won in football field of team B. On the other hand, 75% of the victories of team B are obtained while playing at home. So you can observe here, team B has won 75% of the games played in its own field. Okay, 75% of the games it has won when it has played in its own field. So this is the given data. The question is, if the next game is hosted by team B, what is the probability that it will win? Okay, see, observe the question. So next game, if team B is hosting it, then what is the probability that it will win? That's first question. Second question is, if team B has hosted the next match, who will emerge as the winner? See, first question and second question are different. First question is, what is the probability of uh, team B is winning the match? Next question is, okay, two teams are there. Who will win the match? Okay, both are different questions. We have to find out the probability of team B and then probability of team A, and then we can compare and say which one will win if team B has hosted the match. Okay, for that you have to find out the probability of team B winning the match if it is hosted in team B ground. You also need to find out probability of team A winning the match when it is hosted in team B home ground. Is it clear? Okay, first the given data. See, take two variables y and x. Y represents winning the football match. X hosting the football match. Okay, Y means winning the football match. X means hosting the football match. So probability that team A wins, okay, that they have given 65%. So probability of Y means winning the football match. So team A, probability of team A winning the match is 0.65. That means probability of team B winning the match is P of YB is equal to 1 minus P of YA. That is 0.35. Is it clear? They have given probability of team A winning the match. That is YA, 0.65. Team B is P of YB is 0.35. Next, probability that team B hosted the match and it has won. Okay. Probability that team B has hosted XB, even it has won. So 75% time they will win, 0.75. Probability that team B hosted match won by team A. Okay, probability of team A has hosted, but given team A has won, that is they have won 0.35. So first probability we need to find out. Okay, probability that team B hosted the match and it had won. This data we know P of XB given YB 0.75. Probability that team B hosted the match and A has won. This also we know 0.35. But we need to find out probability that team B is winning the next match hosted by itself. Okay. So which is equal to Bayes theorem if you apply probability XB given YB into probability of YB into probability of XB. But we don't know the denominator. Probability of XB we don't know. Probability of XB means overall probability of uh, uh, matches won when it is in hosted in team B ground. So that is nothing but see the denominator P of XB is nothing but P of XB given by A, that is probability of hosted 1 by A, probability of hosted by B 1 by B. So if you, this data and this data, this can be represented written like this. So if you substitute these values, now we know all these values. If you substitute, you'll get this answer. Probability of team B winning hosted in team B ground. Given it is hosted in team B ground, it is 0.5357. Okay. So this is the probability that matches were won by team B and it is hosted in team B ground. Okay. Next, we have to find out probability of team A winning the match when it is hosted in team B ground. We can substitute the formula same. Okay, XB given by A, probability of YA, probability of XB. So if you substitute this, you will get the answer 0.04642. Is it clear? 0.4642. Now, first question was, what is the probability that team B emerge as winner? That is 50%. You can say 53%. Next is among those two teams, if it is played in team B ground, which one will win? Probability of team B is 0.53. This is 0.546. So answer is team B has got highest probability of winning the next match if it is played in its own ground. Is it clear? See again, this question is also given in the was asked in the previous exam paper. Okay, so be careful about the problems. Only thing is you need to understand the given data, given values, what they represent. Once you understand, once you write it in the response, easily you can apply the formula and solve it. Is it clear? So these are few examples for new base as well. In the next, we shall see Bayesian belief network. Okay, thank you.